Hello, Science 20s. I'm going to go through a couple practice questions. As you can see, I pulled these from the textbook, so I'm just going to go through a couple here for practice. As you can see, this is questions 26, 27, 28, and 29, and we're going to take some time to go through and answer these. The first one we're going to answer is, I'm just going to answer one from question 27. So looking at these graphs, determine the acceleration from the information provided in each of the following graphs. I'm going to zoom in on number or letter D. So I made it bigger down here. And what we're going to do now is actually figure out what we need to find for information. Okay, so we see here we have our graph. Now what we're going to need to do is figure out acceleration is equal to my change in velocity over my time, or my change in time, right? We're going to choose 2 points. I'm going to choose this point right here because it's clearly marked, and this point right here because it's clearly marked. So what I have is 0 and -5. Next, I have over here 1, 2, 11, 12, 13 as my time. And I'm right in the middle here. I'm just going to go 4.5. And so this is where it's going to become very, very important that we keep track of our final and our negatives. So what I have here is, when I actually expand it out, I have velocity final minus velocity initial divided by time final minus time initial. Okay. When I plug in my final numbers here first, so all of these will be my final, or my F. All of these will be my initial. So what I have for velocity final is right on here. This is my rise, is 4.5, and I'm going to minus my -5. You can already kind of guess what's going to happen here. When I subtract a negative, we know. And then my final time was 13 minus 0. And anytime we minus 0, yeah, we know what happens. Okay. So we can do quick math in our heads if we want, or as we kind of figured it out, when we go 4.5 minus a negative number, you're just essentially adding them together. So what you get is 9.5, and then I'm going to write it out. You divide by 13 minus 1. Well, 13 minus 0. Anything taking away nothing is just itself. So 9.5 meters per second change in speed, or in my velocity, over 13 seconds, I have an acceleration of 0.7307, and it kind of keeps going on, meters per second squared. And we can round it off because we have our 2 digits and we have 2 decimal points, 0.73 because of significant digits. Okay, so there we go. We got our acceleration quickly from here. Another question, here is questions 1, 2, and 3 from page 204. We're looking at more graphs again. Scroll down just a little. And what we're going to do when we look here, so there's question 3. I'm going to answer questions 1 and 2, or at least kind of briefly talk about how to get started with it. What you need to do is copy this graph, question number 1, into your notes. And then for question number 2, copy this graph into your notes. When you do that, you're going to try and fill in the blanks for the question at hand. Okay. So we're going to look at these first ones, and essentially it's saying copy the position time graph into your notebook, add a graph by sketching the first 8 seconds, so you can see it's blank here, and then for the last 5 seconds, and we're going to use a rough guide. Question 2 is doing the same thing here, and how do they change? I'm going to kind of do them at the same time. So I blew it up here, made it a little bit bigger so we can track through it. I'm going to use red for my position time graph. So right here, I'm going to try to remember to use green for my velocity time graph and how they're different. And you notice position on this side, velocity on this side, so we can start get going. Question says the car accelerated from rest, so that means right here, 0, 0, and traveled 40 meters in 8 seconds. So that's right about there. All I need to do is now connect the line, and hopefully we can draw a nice straight line, straighter than what I kind of did. And I can do better. Oh, you're not going to let me know. Okay, but we have it there. Perfect. So I got my nice red line from point to point. Same thing with the position time graph. The car then traveled an additional 60 meters at a constant speed of 10 meters per second for 6 seconds. From there, the car traveled a final, so we already have that from here to here. It put it in. From there, the car traveled the final 25 meters in 5 seconds, and as it slowed to a stop for the next red light. So it went 25 meters, so it's at the 100 meter mark. So I'm going to cut it in half again, go about 25 meters. I stopped at, what was it, 14 seconds, and plus another 5, so not quite 20. Let's say right about there. I'm going to draw my 2 lines there. So I came to a stop, and I'm going to fill in it in like that. A little bit different. If you're drawing it at home, please use graph paper. Now for green, we're going to do the same thing, except we're going to have some of these details. I'm going to change my color to green. I want this one green. Here, not. Perfect. Okay, it's not going to work. So what we're going to do is accelerated from rest, so that's 0, 0, and traveled 40 meters in 8 seconds. Okay, so that's from here all the way to this point. Okay, let's see if I can change it now. Nope, that doesn't matter. And so we draw our line up there, and then traveled at a constant speed, so it's a flat line because it's just going 10 meters per second. That's the velocity. After that, then it says it slows down, or it's coming the final 25 meters in 5 seconds, so I'm going back to my 19-second mark, and then I just connected here to my last point because I'm decelerating and I'm slowing down, and I come back down. And so you can see how these 2 graphs are very different. Even though it's the same situation, they are quite different. And so as we kind of go through it, we're like, oh, okay, here's my time. I'm slowing down. I'm going that last 25 meters. I'm not talking about anything here. I'm talking about my deceleration. When I talk about slowing down 25 meters divided by 5, I'm going 5 meters per second at that point, but I'm slowing down, right? So I don't go at 10 meters per second, then all of a sudden I'm randomly at 5 meters per second. No, I'm slowing down over those 5 seconds. So as soon as I start pressing the brake, I slow down to 9 meters, 8 meters, 7 meters, 6 meters, and then 4, 2, 1, and then I come to a stop, right? So it's not it's just an average velocity that I'm going. Okay, so we can view these on graphs, and hopefully it makes a little bit more sense now. Please take time to practice them on your own, and have a great day.